Hello everyone. In today's session of CCNA series, I will discuss Cisco Software Defined Access or SDA. Cisco SDA is a solution to build a converged access edge network for the campus LAN. The word access in the name refers to the endpoint devices that access the network, while the software defined refers to many of the usual software defined architectural features. It includes a centralized controller called DNA center with southbound and northbound protocols, with access edge network managed by the controller or centralized network controller instead of managing each access switch as an independent entity. Let's go ahead and look at the architecture of SDA. SDA uses software defined architectural model with controller and various APIs. It still uses the physical network uh, with switches and routers, cables, and various endpoints. At the center sits the digital network architecture or DNA center controller, which is used for SDA network, with human users making use of graphical user interface or GUI and automation using APIs. The southbound side of the controller contains the fabric, underlay and overlay. We will discuss about these terms in details, starting with SDA underlay. In software defined access, the underlay network refers to the physical network architecture that or physical network infrastructure that provides connectivity between devices in the network. It is the foundation on which the overlay network is built. You can build the SDA underlay network in two ways: using existing gear for the SDA underlay and using new gear for the SDA underlay. So you have two choices. Using existing gear for the SDA underlay, like in this method, you use their existing campus network and add new configuration to create an underlay network while still supporting their existing production traffic with traditional routing and switching. Alternatively, uh, the company can also purchase new switches and build the SDA network without concern for harming existing traffic and migrate those endpoints to the new SDA network over time. SDA can be added into the existing campus LAN, but doing so has some risk and restrictions. Because of the possibility of harming the existing production configuration, DNA center should not be used to configure the underlay if the devices are currently used in production. The existing hardware must be SDA compatible, with different models supporting depending on the different SDA roles. The device software level must meet the requirement based on their roles. The SDA underlay configuration requires you to think about and choose the different SDA roles filled by each device before you can decide which device to use. So there are different nodes used in SDA underlay according to their roles. These nodes are, starting with fabric edge node, a switch that connects to endpoint devices similar to traditional access switches. Then we have fabric border nodes, a switch that connects to devices outside SDA control. For example, switches that connect to the WAN routers or to an ACI data center. Then we have fabric control nodes, a switch that performs special control plane functions for the underlay, requiring more CPU and memory. So let's go ahead and look at another method by using new gear for the SDA underlay. With new hardware for the SDA fabric, that is a greenfield design. It gets rid of many of the challenges that exist when deploying SDA on existing gear. You can simply order new compatible hardware and software. Uh, DNA Center can automatically configure all the underlay features required. The advantages of getting new devices, DNA Centers automatically recognizes and does the configuration automatically. Basically, instead of switching, we are using routing in routed access. And with DNA Center, this can be configured automatically for SDA underlay. It uses a design called routed access layer design, where all the switches act as a layer 3 switches. The switches uses the ISIS routing protocol for routing, and all the links between the switches, single links or ether channel are routed as layer 3 links, not layer 2 links. As a result, STP or RSTP is not needed. With the routing protocol, instead, choosing which links to use based on IP routing table. The equivalent of traditional access layer switch, an SDA edge node, acts as a default gateway for the endpoints. You can see uh, the switches, the layer 3 access layer 3 switch is acting as a default gateway. So as a result, HSRP or any FHRP is no longer needed. All switches in the distribution and access layer are used in SDA network as layer 3 switches. You can see in the topology shown. This network which uses layer 3 access layer switches is called routed access layer switch, routed access layer network. So let's go ahead and see another important thing, that is SDA overlay. SDA overlay is the logical part of the Cisco SDA access architecture. It is a virtual network that is created on top of the underlay network to provide advanced network services such as segmentation, policy enforcement, and automation. Here the VXLAN tunnels are created between SDA switches to provide data transfer between different fabrics. At the first fabric edge node, the frame is encapsulated with VXLAN and sent to the network through VXLAN tunnel. At the other end, VXLAN encapsulation is removed and the data is forwarded to the other end. With an overlay network, a virtual network is built by using an SDN controller, or you can say Cisco DNA. Cisco and DNA, this controller decides a path that will be used on, that will be based on policies, and the path from end to end, you can call it as a overlay network. In SDA network architecture, overlay and underlay are collectively known as SDA fabric. So this fabric consists of three components: data plane, based on the VXLAN or virtual extensible LAN. Cisco choose the VXLAN protocol to create the tunnel used by SDA. When an SDA endpoint sees a data link frame into an SDA edge node, the ingress node encapsulate the frames and send it across VXLAN tunnel to egress edge node. Then we have control plane, which is based on location identity separator protocol or LISP. Then another plane we have is policy plane, which is based on Cisco Trust Sec or CTS. That's it for this session. I hope this was informative for you. Thank you for watching.